All right, so we're going to be talking about similar polygons. So just a quick reminder, congruent is a term that we used a lot last semester and up to this point. Congruent means same size and same shape. And we have this symbol right here that went with it, equal sign with this little squiggly mark over it. In this chapter and this section in particular, we're going to be focusing on similar polygons and with a little bit more of an emphasis on triangles, but similar polygons in general too. Polygons that are similar have the same shape, but not necessarily the same size. So one of them is going to be bigger than the other. So if we look at these two examples here, in the first one, triangle 1 and triangle 2 are similar. They have the same relative size, relative shape, but one is scaled up compared to the other one. Whereas in the second picture, these are not similar because you can't just make triangle 1 bigger and match triangle 3. They're just kind of different triangles. All right, let's go ahead and move forward, be a little more formal with this. So the definition of similarity is this: two polygons are similar if and only if all of their corresponding angles are congruent. So corresponding angles are congruent, that's the first part. And their corresponding side lengths are proportional. So those are two pieces to that. Let me just put a box around that second part. Corresponding sides are proportional. So when we're trying to demonstrate that two polygons are similar to each other, we actually need to make sure we know both of these things. So we need to make sure that all the corresponding angles are congruent and that these sides are proportional. So we're going to still talk about proportions here because we're going to need to use that to talk about similarity. Here we have a nice picture of these, I guess they would be maybe trapezoids, and they are similar to each other. All of the angles that correspond with each other are congruent. So angle A and E correspond and they're congruent. Angle D and H, same thing. B and F, C and G, right? All of those corresponding angle pairs are congruent to each other. So we have that first part. And then the second part, all of these ratios of the corresponding sides are going to be equal. So they're going to be proportional, right? If we do 6/12 for that ratio right there, 6/12, that's 1/2. If we do, let's just pick another side pair here. If we do 5.4/10.8, those are corresponding sides there. That's also equal to 1/2. So that's going to be true for all the side pairs. You can go ahead and go through the rest of them. 5/10 is 1/2. 4/8 is 1/2. So all of my sides, all my corresponding sides make an equal ratio. So therefore, these are similar. And this right here, this is our symbol for similar. It's just that little squiggly part. It's actually part of the congruent symbol, right? So congruent symbol has two pieces to it. It has the similar symbol and it has the equal. So they are the same shape and equal sizes. So congruent is like a more powerful similar. Similar is just same shape, just that part. Okay, let's go ahead and move forward. This is the day 2 where we got with this. So let's just do a quick proportion. We're going to end up solving a lot of proportions when we deal with similar triangles or similar polygons. Let's just go ahead and solve this one real quick. Cross multiplying. 3 times 5x minus 7. Feel free to pause this and try it on your own if you want to. And then 14 times 20 minus 2x. So these are our two cross products. We make sure to distribute here. 3 times 5x is 15x. 3 times 7 is 21. 14 times 20 is 280. 14 times 2x is 28x. So there we go. Go ahead and finish solving this. Divide that, we get 7. So x equals 7. You can always plug that in, make sure that works. So 5 times 7 minus 7. It's 35 minus 7, so I get 28 on top. 20 minus 2 times 7, which is 14. 20 minus 14 is 6. And then we want to check to make sure these are equal. And yeah, this one over here, the left side does reduce. We divide both of those by 2. We get 14 over 3. So it does work out, checks out. It's worth doing. You might as well check it. Just make sure you didn't make a mistake. Okay, let's go ahead and keep talking about similar polygons. Remember, thing to remember here with similar polygons is there is 2 parts to our definition here, right? All the corresponding angles are congruent, so make sure all of your angles are congruent, whether we know the exact measurements or we can use some sort of theorem like vertical angles or corresponding angles or alternate interior or whatever to prove things. The angles are congruent, and then the corresponding sides are proportional. So that's where we have to make those ratios, make sure that they're all equal to each other. Okay, so are these rectangles similar? Well, rectangles, that gives us some information, right? If these are rectangles, then all of these are right angles. So that satisfies that first part. All of my angles, all of my corresponding angles are congruent. Obviously, they're all 90 degrees. So part 1, check. Part 2, a little less clear, but again, we are dealing with rectangles here, so opposite sides are congruent. So if this is 4, this is 4. This is 12, this is 12. If this is 6, this is 6. If this is 16, this is 16. So what we're dealing with here is we want to make sure that if we write ratios of the corresponding sides, so this side here, PS, would have to correspond with this side, TW. Those are the short sides of our rectangles. So we're saying that this ratio needs to equal a ratio of any of the other corresponding sides. And so the other corresponding sides I want to look at here are 12 and 16. So let's see, is that equal? Is it equal to 12 over 16? Notice I took on top in the numerators here, I have a side of this smaller rectangle, a side of the smaller rectangle, and then in the denominators, I have the bigger rectangle. Anyway, are these equal? Well, no, they are not. And let's talk about why. Let's reduce them. 4 over 6 reduces to 2/3. And these reduce, they divide by 4 to 3/4. So these are not equal. So in this case, we can answer no. The angles were congruent, but the sides were not proportional. Proportional. I know I didn't spell it right, but you get the point. So no, these are not similar rectangles. They're rectangles, and rectangles are sort of alike each other, but they're not similar. Similar is a very strict mathematical definition, and this does not satisfy it. Okay, let's go ahead and look at another one here. Are these triangles similar? Okay. So we have some angles. So again, one, we're looking at the angles. Whoa. One, we're looking at the angles. Are the corresponding angles congruent? Well, okay, so we have angle A and angle D. So that's one set of angles. Angle A is congruent to angle D. So that's one set. We got angle B and angle E. So angle B is congruent to angle E. But what about these other angles? What about this one's C and F? Are these equal? Yes. If we have 2 congruent angle pairs in these triangles, then by what's called the third angle theorem, C and F also have to be congruent. This is based on, knowing that the angles have to add up to a fixed sum of 180 degrees all the time. This is using, again, what's called the third angles theorem. You'll look it up if you want to. I believe that's in chapter 4 of our textbook. All right, so we got that first part. Yeah, corresponding angles are congruent. We just got that, all 3 pairs. What about the sides? Okay, with the sides, we need to figure out which sides are going to correspond to one another. So in this case, we have actually a few different ways to do that. I'm going to go kind of through each way. So if you know all of the side lengths specifically, like the numbers, then what you can do is just match them up in order from shortest to longest. That's kind of the easiest. If you know all the numbers, you can just do it that way. So you can say, all right, well, 12 is my shortest side here. It's going to go with this shortest side, 16. That's kind of your easiest way. So that can be one of our ratios. Let's do it as 16 over 12. Doesn't matter. I'm just going to set a way to write my ratios. So I did this triangle on top, this triangle on bottom. Another way to do it is so I could keep doing that. I could put the middles together and then the longest together as well. But I'm gonna show other ways here. The next way to do this would be to look at the angles. And what I mean by that is the angles that the side is in between. So for instance, this side 24 is in between a double marked and a triple marked. So that's going to go with this one right here because it is in between a double mark and a triple mark. It's between the same marked angles. So those are going to have to correspond. That's another way we can do that. And then the final way to do it is to look at the angle that is across from it. So for instance, this side 20 is across from the triple marked angle. So it has to correspond to 15 because it is also across from the triple marked angle. So those are kind of the three main ways to match these up. You can either put them all by order. So shortest goes with shortest, middle goes with middle, longest goes with longest, and set them all up that way. You can look at the angles they're between, triple mark, double mark, triple mark, double mark, they have to go together. Or you can look at the angle they're across from. Across from triple mark, across from triple mark, they have to go together. So kind of three main ways to look at that, just so that you make sure to match up corresponding sides appropriately. Okay. Are these equal? Again, because this is part two, we're looking at the sides. Are all of these side pairs proportional? Are all of these ratios actually equal? Okay, let's go ahead and simplify them. 16 over 12, those are both divisible by 4, so that reduces to 4 over 3. Okay, 4 over 3. 24 over 18, again, those are also divisible by a common factor of 6 this time. So divide by 6, we get 4 over 3. Okay, that's good. Two are the same. And then last one, these are both divisible by 5. 20 divided by 5 is 4. 15 divided by 5 is 3. Awesome. Yes. So yes, equal ratios. Equal ratios. So that means that the sides are proportional. Has to be true for all of the side pairs, but it was. We matched them all up. So now with both of those parts satisfied, the angles were congruent, the corresponding sides are proportional. Yes, these two triangles are similar to each other. So yes, they are similar. Okay, let's go and clear this. So the next thing we have here is the similarity statement. So this is just like the congruent statement. The order that we name a triangle in a similarity statement, the way they're both named, they need to match up. So when you read it, you should be able to figure out any parts that you want that are going to match up. So for instance, angle E and angle C have to be corresponding and congruent to each other if these indeed are similar triangles. So angle E and C. We don't even need the picture to do that. We can just get that from the statement. And then also V and A, V and A, and then our last set here, L and T. So the statement tells us that what angles need to correspond. Also works with the sides as well, right? The sides work the same way. Let's just look at one of the sides, for instance. So what side would correspond? Oops, that's not what I meant. What side would correspond with CT? You can see it here, yellow. Well, CT, that's the first letter and the third letter of this name. That should correspond with EL, the first letter, third letter, EL. And you can see that in the picture, worked. Those were in the same position. So yeah, it does work that way. Just to finish out the rest of them, right? CA are the first two letters, should go with EV. So CA, EV. And then our final answer here, TA or AT goes with VL. AT, VL. So the order that we write these names is important. If you're given a similarity statement, you need to take the information out of that statement to know what parts go together. And when you're writing the statement, you need to be careful that you do write it in this corresponding manner. I didn't fill out the names here, but I did speak about them, right? So Angle C corresponds with E, angle A corresponds with V, angle T corresponds with L. Side CT corresponds with side EL, CA corresponds with EV, LV corresponds with TA, right? You can see it in the picture there, the color coding we did. All right, and then the last problem for this part, we have using the triangle similarity set of the proportions. So in this case, we know that these two triangles are similar. And in fact, we're given a triangle similarity statement. Statement very useful. Remember, for that last side we just looked at, this gives us a lot of information. This tells me angle M and angle X are corresponding and congruent. M, X. This is helpful here because these triangles aren't really oriented the same way. Whether they're like rotated or flipped or something, they're not quite oriented the same way. It's not quite as obvious as it was in that last picture. So this statement is a very good help. N goes with X, N goes with Y. We'll double mark those. And the last one, P, corresponds with Z. Okay. We might have been able to figure this out, without going through it that way, but this was very helpful. I was just able to go right through it and do it that way. Okay. What we're trying to do with this problem is we're trying to solve for X, trying to solve for the value of X. In this case, X has to do with the sides. Since we know these triangles are similar, what we know about the sides is that the sides are proportional to one another. We need to set up a proportion. So let us try to set up a proportion. Remember, proportion is two equal ratios. Okay. Since we're solving for X, we know we want to have X involved in this. So let's just say this right here. What side is going to correspond with this one? Well, it's between our blue and our red, so our triple mark and our double mark. It's going to go with this one, between the blue and the red, the triple mark and the double mark. Those two sides correspond with one another. So 4x minus 10 over 75, that's going to be one of my ratios. And what's my other ratio going to be? Well, let's just take a look here. Well, the other side we have here is this one, x plus 5. That's the green and the blue, the single mark and the triple mark. That's going to go right in between here. So those two sides correspond. Notice that as I'm writing these, as I look at these two ratios, the things on top, these on top, both come from this triangle, and these on bottom both come from this triangle. That's that consistency. We got to make sure we have that consistency. Otherwise, we have a wrong proportion. It won't work for us. All right. Then to solve for X here, it's just simply a matter of actually solving it. We're going to do cross products and solve that. So feel free to pause it and try to solve it on your own. I'm going to go ahead and get that started. I'm not going to talk through this. I'm just going to go ahead and do it. Go ahead and divide that, get our final answer. 675 divided by 45. So x is equal to 15. X equals 15. For this problem, that's all we got to do. That's the value of x. That's the value of x. We're all done. We could do more with this. We could actually substitute that number in and figure out this side length. So 4 times 15 minus 10, right? We could actually do the calculation here. Figure out that this is 50. 15 plus 5, we can figure out this one's 20. We can use the value of x to answer further information about our triangles, but in this case, this is all we're looking for, so feel free to stop right there. All right, we're going to go ahead and talk about this as our last thing, and actually this and the next one is our last thing in this video. So there's two common situations that show up with similar triangles. So these are really focusing on similar triangles, triangles in particular. This idea of overlapping triangles, or a triangle that's kind of inside of another one, and its sides kind of overlap each other. So we have this triangle here that's sort of inside of this bigger one, and its sides overlap it. In this case, these two triangles will always be similar if these sides are parallel. There are some triangle similarity shortcuts we'll learn about in later chapters, but these will always be similar. Let's go ahead and demonstrate that they will be, just to kind of get an understanding of what's going on. But if these are parallel in this case, they're always going to be similar. If they're not parallel, if this line is like at a different angle or something, and it's not parallel, then it doesn't work out. But as long as these two bases here are parallel, these two triangles will always be similar. It's a common thing that shows up. Well, anyway, why are they going to be similar? Well, that's because, one, they share an angle. So that's one set of congruent angles. These angles right here are what are called corresponding angles. Not corresponding in the sense of they're the same part of each triangle. They are corresponding because they have parallel lines. This is a transversal, and they're in the same position. Parallel lines, transversal, same position. So these are congruent by corresponding angles. And then same thing on this side. These are also what is considered corresponding angles. Corresponding. Because again, parallel lines, transversal, left of the transversal, above the line, same position. So all the corresponding angles are congruent. Second part, well, these are kind of made up side lengths here, but let's just demonstrate that in this case, they are actually equal ratios. I'm going to do the small triangle over the bigger triangle, just to be clear about how I'm going to be setting up my ratios. So for this one, I have 12 over this whole length, right? So be careful here. It's not 12 over 4. It's 12 over 16, this whole side here. So 12 over 16. A lot of people get in trouble and they write 12 over 4, and that doesn't really work here. That would reduce to 3/4. Cool. Let's go ahead and write the other ratios. We have 9 over 12. Those sides would correspond. 9 over 12. Also reduces to 3/4. Divide those by 3. So far, so good. And then we have 15 over the whole side here. 20. 15 over 20. Which again, it's going to simplify to be 3/4. Divide those by 4. So yeah, these are similar. We're able to kind of demonstrate it in this situation, but we're going to learn that there are some shortcuts for this. And it turns out this is actually enough, but it's a little bit technical. So yeah, overlapping triangles is a situation where we're always going to have similar triangles. We'll come back to that one. Triangles made by two transversals. All right, going back to chapter 3, we have parallel lines right here and here, and we have what are called transversals. So this line from B to C is a transversal because it touches the parallel lines, and we'll do this one blue, AB, also a transversal. In this situation, these triangles are also always going to be similar. They will always be similar, but let's again kind of demonstrate it in this case, just make sure it makes sense. So anytime we have parallel lines, transversal, we need to be looking for things. One of the things we need to be looking for last time that we saw was corresponding angles. So angles that were in the same position. I'm going to go ahead and make that a little bigger. Another thing when you have parallel lines you should be looking for are alternate interior angles, which we have in this problem. There are some other ones here, but those are the two we want to look for. And then another thing we often will find in many different situations, not just because we have parallel lines here, but vertical angles. And we have some vertical angles in this problem. So let's see if we can identify some of these two in particular in this problem. Alternate interior angles and vertical angles. So first off, right here, angle A and angle D. These are what are called alternate interior angles. They're inside of the parallel lines, they're in between them, and they're alternate. They're on different sides of this blue transversal. So they're congruent. Same thing here with this one at C and this one at B. They are also alternate interior angles. They're between the parallel lines and on alternate sides of the transversal, the green transversal this time. So that's 2 of the 3 angles, and then vertical angles. Right here in the middle, we have these 2 vertical angles. So all of the corresponding angles are congruent. We got that first part. Turns out that's enough, but we'll get that in the next chapter. Let's now also compare all the ratios. Fortunately for us, we've actually already color-coded it for ourselves. Yeah, let's just write the ratios. I'm going to do the big triangle on top and the small triangle on the bottom, just as a reminder of kind of writing that for myself. So I'm doing 30, which is this side, corresponds with 7.5. I'm going to go and just divide that. 30 divided by 7.5. Okay, that's actually a whole number. That's 4. 16 would go with 4. 16 corresponds with 4. That also reduces the whole number, so good to go. Reducing great so far. And then 11 corresponds with 2.75. If you can't quickly identify these corresponding parts, take your time. Make sure, use the angles to clue you in. Double mark, single mark, double mark, single mark. These go together. Triple mark, single mark, triple mark, single mark. These go together, right? Use those clues to help you out as well. And this one, just use my calculator here, also equals 4. So all of the corresponding side pairs are proportional. So yes, these are similar. Again, turns out this is enough, but we'll get to that later. All right, and we'll stop the video for right now at this point, and I'll see you guys in part 2.